On behalf of the USDA Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we would like to thank you for your interest and participation in this third public meeting for the Supplemental Watershed Plan Environmental Assessment of Settingdown Creek Dam number 56. The purpose of this planning study is to assess the Settingdown Creek 56 watershed, to evaluate the performance of the existing watershed structure, and develop a plan to address any compliance issues with the dam. Also, the plan will try to determine if federal financial assistance will be available to address compliance issues, and to determine if the project sponsors would like to continue operation of the dam within the NRCS watershed program. Public participation is of great importance for the planning process. The objective of the planning study is to inform the public and watershed stakeholders of the effort. The planning study requires a series of public meetings. The first and second public meeting presentations included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed and the specific dams included in this planning study, and an opportunity for the general public and participants to submit questions and comments regarding scoping topics, project opportunities, and concerns. The second public meeting included a list of potential rehabilitation alternatives that are being considered by the planning team to address compliance issues with the dam. The first public meeting was posted to Schnabel's YouTube channel from August the 7th until August the 17th, 2020, and the second public meeting was available from December 18th, 2020 until January 4th, 2021. Please note that the first and second public meeting presentations have been reposted to Schnabel's YouTube channel for those interested in viewing the presentations and the content described above. The third presentation will provide an overview of the Settingdown Creek watershed and the dams included in the study. It will include a review of the existing conditions associated with Settingdown Creek Dam number 56 and shortlisted alternatives to address issues with the dam will also be presented and discussed. At the end of this presentation, there will be an opportunity to submit questions and comments regarding the planning study and this presentation. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. The creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage area, and the original watershed work plan, which was prepared in the early 1950s, provided for the construction of 15 floodwater retarding structures known as the Settingdown Creek dams. This slide presents a map of the Settingdown Creek watershed. The watershed is delineated in red and begins at the confluence of Settingdown Creek and the Etowah River at the downstream or west side of the map, or the left side of the map. The watershed, as you can see, stretches in an upstream direction toward Georgia 400 at the east end, and several key highways located in northern Forsyth County, Georgia, are indicated for reference. This slide presents a delineation of the watershed overlain on aerial photography taken from the early 1960s, shortly after the Settingdown Creek dams were constructed. As you can see, The watershed has changed some over the past 60 years with residential and commercial development entering this region. Focal points of analysis and study associated with the plan include upstream areas, areas upstream of the dams that are subject to flooding, as well as an analysis of the need for additional storage capacity. Downstream areas with regard to flooding associated with the 2 through 500-year storm events, as well as hypothetical breaches of the dam. An evaluation of the hydraulic capacity of the existing spillway outlet works was performed for various storm events. An analysis of the economic and social benefits provided by the dam was performed, as well as an assessment of environmental and cultural resources in the vicinity of the dam. This slide presents another map of the watershed and includes the locations of 6 dams that are currently being planned within the watershed. You'll note that most of the dams are located at the very upstream or eastern end of the watershed that are being studied. Settingdown Creek Dam number 56, which is the subject of this presentation, meets Georgia Safe Dams Program criteria to be considered a Category 1 high hazard potential dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam requires an operating permit from the Safe Dams Program. Previous dam assessments indicated that the dam does not comply with current SDP rules and requirements, which necessitated this planning study to further investigate its performance. The dam is not exempt from SDP rules and requirements. One purpose of the planning study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety regulations. The Georgia Safe Dams Program is fully aware of this dam, its classification as a high hazard dam, and that the dam is being studied by the planning team. Some original design features of the dam include that the dam was not originally designed as a high hazard dam. The purpose of the dam is flood mitigation, and a secondary purpose is sediment accumulation and storage. The principal spillway for the dam is composed of a reinforced concrete riser structure and a nearly vertical pipe or conduit that connects the riser structure to the downstream end of the dam, where flows through the pipe discharge into an outlet channel beyond the downstream slope. A vegetated earthen auxiliary or emergency spillway is also included with this dam, which is meant to convey flows associated with low frequency, high intensity storm events. Here's a map of the watershed once again, with the location of Settingdown Creek Dam number 56 indicated in yellow at the upper right-hand portion of the watershed. Settingdown 56 is located west of Georgia 400, north of Hubbardtown Road, and south of Plainsman Circle. Construction of the dam was completed in 1954. The dam appears on the National Inventory of Dams and has a surveyed height of 33 feet. The drainage area is almost 1 square mile, and the design storage capacity of the dam is 283 acre feet, which includes consideration for sediment storage, flood storage, and surcharge storage. This aerial photo taken from the 1950s shows the location of the dam shortly after it was constructed. you can notice that development upstream of the dam is limited, as well as downstream of the dam is limited. We'll fast forward to a more current aerial photo and notice that the area immediately upstream of the lake has been developed with a residential subdivision, and some development has occurred immediately downstream of the dam on either side of the creek that discharges from the principal spillway system. Note that Georgia 400 is located immediately to the east or to the right of the dam and lake in this view. A limited topographic survey was performed to assist with the planning effort for this dam. The topographic survey included key elevations taken for the crest of dam, the principal spillway system, and the auxiliary spillway channel. The principal spillway system is located to the left of the dam. There's a gray square located in the lake near the left side of the upper left side of the lake in this view. The auxiliary spillway for the dam is located near the right end of the dam, and you can see this aerial photo was taken shortly after the dam was cleared during the summer of 2020. This is a topographic site plan of the dam. The principal spillway is indicated near the left side at station 300 of the dam center line, and the auxiliary spillway is located at approximately station 700 in this view. You can see that wetland areas delineated as part of the environmental survey have been identified backing up to the downstream toe of the dam. As we view this, keep in mind that downstream is up on the page and the lake is down on this particular view. Also of note is the presence of a sanitary sewer line near the right end of the dam. The sanitary sewer runs through a portion of the auxiliary spillway channel and then turns, crosses the creek and runs downstream, generally parallel to the creek that is downstream of the dam. This photograph is taken from the crest of the dam, looking slightly in the upstream direction toward the inlet channel of the auxiliary spillway. Indicated on this photo are the concrete riser structure, the upstream slope of the dam, and the crest of the dam. At the top right-hand side of the photograph, you can see some of the houses that are part of the residential development just upstream of the lake. This photograph is taken from the left side of the plunge pool downstream of the principal spillway outlet. We're looking in an upstream direction. The downstream slope of the dam is indicated in this view, along with the concrete principal spillway conduit and the riprap lined plunge pool for the dam. An environmental survey was performed as part of the planning effort. The aquatic resource survey exhibit on the left-hand side of this slide shows the limits of survey performed for dam number 56, along with the locations of streams, wetlands, and open water that were identified. Also shown are locations where invasive species in the form of Chinese privet, which is a vegetative invasive species, are located. As a result of the environmental survey, no protected species were identified or found during this environmental survey work. A phase 1 cultural resources survey of the dam and its vicinity was also conducted. The cultural resource survey map on the left side of the slide shows the location of survey transects and shovel tests that were performed. A literature review was also performed to identify potential historic items of concern within the vicinity of the dam. The study concluded with no archaeological resources recorded. The dam, being older than 50 years, is technically eligible for the National Registry of Historic Places, but its listing is not recommended. Although the dam is old, there are no unique features or characteristics of the dam or its design that merit its inclusion on the National Registry of Historic Places, in the opinion of the Cultural Resources team. No additional cultural resources work is recommended for this dam. As part of the evaluation of the dam and its downstream areas, a dam breach study and analysis was performed, and this inundation map was generated. The inundation map indicates the extents of flooding were the dam to fail in a catastrophic manner on a sunny day. The map shows the extents of this flooding in blue, and several potential structures that would be impacted are also identified on this map. Please note that the location of the dam is at the upper right-hand side of this view, or to the northeast, and the flood wave for this dam would progress in a generally east to west direction along Settingdown Creek. In addition to the breach analysis, downstream flooding analysis associated with the 2-year through 500-year 24-hour storm events was considered. This map shows the extents of flooding associated with the 100-year and 500-year storm events in yellow and purple, respectively. Additionally, some structures would be subject to flooding during these events, and those structures are indicated with the red numbered houses. Also, as part of the analysis, storms were routed through the dam and spillway outlet works to determine flood levels upstream of the dam. The normal pool and elevations associated with the auxiliary spillway control section and dam crest are indicated on this view, as well as water surface elevations associated with the 100-year and 500-year storm event. Additionally, storms greater than the 100-year and 500-year storm event are shown. The Georgia Safe Dams Program storm event is indicated in yellow, and the NRCS design storm event elevation is indicated in green. Note that there are 2 residential structures around the upstream edge of the lake that would be subject to flooding during the Safe Dams Program storm event and or the freeboard hydrograph storm event, which is the NRCS storm. This is a review of the existing deficiencies identified with the dam. Based on a review of records, the normal pool elevation of the lake was raised by 11 feet sometime during the 1970s without authorization. This blocking of the principal spillway riser structure creates an issue with the level of downstream flood protection that the dam was originally designed to be able to provide. As noted previously, the dam was cleared of trees and inappropriate vegetation during the summer of 2020. An underwater inspection of the riser structure concluded that portions of the slide gate assembly are worn and or corroded. It's unclear whether or not the gate system is operable at this time. Portions of the riser concrete are cracked and or spalled, and a closed circuit television inspection or CCTV inspection of the interior of the principal spillway conduit was performed, and the condition of the pipe was determined to be acceptable for continued use. With regard to hydraulic deficiencies, during the Safe Dams Program design storm event, which is 1/3 of the probable maximum precipitation, the dam overtops by 1 foot and the auxiliary spillway breaches. With regard to NRCS criteria, the auxiliary spillway engages prior to the principal spillway hydrograph storm event, which is a qualifying or evaluating storm event for the NRCS. The auxiliary spillway control section is about 2 feet lower than required by NRCS regulations, and during the NRCS design storm, which is 100% of the probable maximum precipitation, the dam overtops by 3 feet and the auxiliary spillway breaches. The planning team has shortlisted 3 alternatives that will be discussed in this presentation today. One is a no action alternative that would not take advantage of federal investment and would involve either the breaching of the dam or rehabilitation of the dam to state dam safety criteria. A decommissioning alternative is required for consideration as part of this planning process, and a NRCS rehabilitation that would take advantage of potential federal funding has also been shortlisted for this structure. We note that development of the NRCS rehabilitation alternative includes consideration of upstream non-flood control ponds, as well as uncertainties associated with climate change. We'll start with the no action alternative, which is also known as the future without federal investment option. For this particular dam, it would be more cost effective for the project sponsors to permanently breach the dam in accordance with Georgia Safe Dams Program requirements. This would not be a total removal of the embankment, but a portion of the dam would be removed so that the lake would be permanently drained and maintained in an empty state. This alternative would involve revegetating the resulting lake bed to stabilize it. The existing principal spillway system, including the riser and conduit, will be removed, and the resulting breach channel through the embankment would be stabilized with stone riprap. Breaching the dam to state criteria is a less costly alternative than rehabilitating the dam to meet the Georgia Safe Dams Program design storm requirements. This site map shows what an SDP level breach of the dam would look like. You can see the left end of the dam where the principal spillway system would be excavated. The slopes will be laid back and revegetated, the principal spillway removed, and the bed through the dam footprint stabilized with stone riprap. The lake would be permanently drained as a result of this activity, and the lake bed would be stabilized with permanent vegetation. The decommissioning alternative would involve similar aspects as the Safe Dams Program breach. However, it's a little bit more involved. This would involve removal of most or all of the existing dam and principal spillway system, reconnecting the grade of the original floodplain, stabilizing the lake bed with vegetation, and stabilizing the primary channel through the footprint of the dam with riprap. Decommissioning the structure would improve flooding upstream of the dam, but downstream flood benefits would be lessened or lost. The planning team has evaluated and quantified the downstream benefits currently provided by the dam, as well as the loss of those benefits were the dam to be removed. This site plan shows what the removal of the majority of the dam would look like. You can see some similarities with the Safe Dams Program level breach. The main difference is that the majority of the dam would be removed and the floodplain would be reconnected with this alternative. The lake and the areas within the immediate vicinity of the dam would likely revert to wetland areas. Got a couple of photographs with examples of what a removal of a dam would look like. You can see in this photo, a dam has been excavated down to its foundation, and so that the lake does not impound a permanent pool of water. Water will always be flowing through the breach, hence the need for stone riprap stabilization to keep the ground area stable with permanent flows passing over it. This is just another view of dam removal option and what it would look like. The final alternative that we'll discuss is the future with federal investment alternative. This alternative would allow the sponsors to cost share the rehabilitation effort with the federal government, with the NRCS, to rehabilitate the dam to NRCS standards. This alternative would involve raising the crest of the dam to the current maximum water surface elevation associated with the design storm, regrading the upstream and downstream slopes to 3:1, constructing a riprap lined wave berm across the upstream shoreline of the dam, and decommissioning or closing off the existing vegetated auxiliary spillway with compacted earth fill up to the proposed dam crest elevation. The principal spillway system would be rehabilitated by removing and replacing the principal spillway riser structure. We note that since the lake was raised without authorization in the 1970s, that this alternative would involve returning the normal pool of the lake back to its originally designed elevation. So the lake would be 11 feet lower than it is today. The riser structure was blocked off, and water spills over the crest rather than through the intended low-level orifice of that riser structure. So the new principal spillway would establish a lower normal pool than what is evident today. Principal spillway rehabilitation would also include extending the principal spillway conduit. As we noted earlier, the conduit is in acceptable condition, so the dam would not need to be completely excavated to replace that pipe. However, the pipe would need to be extended to accommodate changes to the principal spillway riser and the embankment modifications discussed above. A plunge pool would also be constructed of riprap at the downstream end of the extended conduit. The auxiliary spillway necessary to pass the NRCS design storm event for this dam would need to be 120 feet wide and would be a reinforced concrete labyrinth crested chute spillway. This type of spillway is a compressed weir, and it would have 5 cycles. The spillway would be constructed over the embankment, giving consideration to access from both sides of the dam. The spillway would include a reinforced concrete stilling basin and a riprap lined apron to dissipate energy associated with high flow storm events. This site plan shows what the Labyrinth spillway would look like over the embankment. You can see that we're showing the improvements to the principal spillway system at the left side, the installation of a riprap lined wave berm on the upstream slope to help out with wave erosion, and the Labyrinth Weir spillway in the middle of the dam. This spillway is relatively large. The factors that necessitate the spillway having this size are one, the size of the watershed, two, the relatively small available storage in the lake, and three, the fact that the earth spillway is incapable of passing the flows associated with the design storm event without breaching. You'll note too that the sanitary sewer system shown may require some slight modifications depending on the final design and layout of the spillway system, but those modifications would also be accomplished during the rehabilitation effort for this dam. Here's a profile view of the Labyrinth spillway. You can see that the spillway, the Labyrinth is located at the top or middle of the profile view. Water would spill over that wall onto a relatively flat apron before being conveyed down the 3-to-1 chute and into the stilling basin and riprap apron at the downstream end of the spillway. Here's an example of this is a 5-cycle Labyrinth spillway that has been constructed over an earthen embankment dam. You can see that this one includes a pedestrian bridge. It's located in a park, but this gives you a good idea of what the spillway system would look like for this particular dam. Here's another example of a Labyrinth crested spillway over an earthen embankment dam. This one is a smaller spillway with 2 cycles, smaller Labyrinth spillway with 2 cycles. We're looking at this one from the downstream vantage point, and we're looking in an upstream direction. You can see the new riser structure, or at least the top of the new riser structure in this view just upstream or above the Labyrinth spillway. Based on the results of the planning study and discussions with the project sponsors, including representatives of the state NRCS, the planning team is presenting the locally preferred alternative for this dam as the future with federal investment alternative. As just described, this is the alternative that would result in a new principal spillway riser structure that would establish the normal pool at the original design elevation of the lake. The dam crest would be raised, the embankment slopes would be flattened, and the auxiliary spillway necessary to pass the NRCS design storm event for this dam would be a Labyrinth crested concrete auxiliary spillway. As indicated at the beginning of the presentation, public participation is of great importance to the planning team. We invite you and project stakeholders to submit questions and comments regarding the plan development and the alternatives discussed in today's presentation for consideration by the planning team. Questions and comments may be submitted by accessing a Google form at the web address provided below. Please note that the link is not active or clickable in the YouTube video. However, in the comments section directly below this video, a clickable link should be provided. In the event that you cannot access the clickable link, you may type in the HTTPS web address shown here into a search engine or browser address bar such as Google Chrome or Internet Explorer to access the Google form. So please feel free to pause this recording if necessary to copy down the address to access the Google form. The planning team will accept questions and comments associated with this public meeting through Monday, July 19th, 2021. Once again, on behalf of the project sponsors, we would like to thank you for your interest and participation in this third public meeting. We encourage you to submit your questions and comments if you have any in a timely manner so that those can be considered and included as part of the planning process. Thanks once again for your time and interest, and we trust you have a good day or good evening.